The agenda, we are trying to keep it within or around 30 minutes so that there's plenty of time for Q&A. I will be discussing a short history of this application note and the concepts within, and then Robert will help you through all the details, what the implementation is for the different OCPP versions, the key value matrix, some specifics on OCPP 1.6, and finally some very concrete examples. And then hopefully you guys will have a lot of good questions for us. So actually this effort started out as a attempt at a white paper from measurand Eichrecht, which is the German calibration law. It's a law that has been in effect since 1970, so way before EV chargers. It has nothing to do with EV chargers. The goal of that law is to protect consumers from incorrect invoices by having incorrect measurements. So this is meant for all measurement devices, not specifically for EV charging, but since we are focusing on EV charging, that's the aspect of the measurand Eichrecht that we started to look at. One of the problems, or the biggest problem that that this field experienced, is that the law describes what it is and why it is, but not the how, which means that everybody has had to invent their own solution. Every charge point manufacturer had to invent their own Eichrecht solution, go through certification. The German authorities learned, especially in the beginning, from each certification process. So those who got their certifications early were luckier than some later because they learned. So it hasn't been a consistent experience. And what's also important to note that formally the certification is only valid for a certain period. So strictly speaking, after a certain period, recalibration is needed. And the certification also applies to very specific software and hardware versions. So if you change anything formally, in some cases you would need to recertify. Fortunately, it's not that strict, but it's something to keep in mind that you might get a certification at the beginning, but at some point in time, if your chargers are there in the market for more than 7 or 8 years, that there might be a need for recertification. Perhaps not for the charger, but for the meter, but it's something to keep in mind. So I already spoke a bit about this. Everybody needs to find their own solution. It is a charger requirement, measurand Eichrecht, but it's an end-to-end solution, which means that the charge point manufacturer needs to come up with a way to get signed measurements to the CPMS, but then that CPMS needs to implement every specific way of handling that for that specific charge point manufacturer. And implementing charger specifics, that's exactly the opposite of what we intended OCPP to be. It's intended to have a freedom of choice in hardware. So that was basically the driving force behind our effort to try to come up with a standardized way instead of everybody for himself. So why is it not a measurand Eichrecht white paper? The measurement laws also exist in other countries. Germany has probably the most strict one, but we try to make sure that this solution can be used also in other situations, in future situations where other countries also consider measurand Eichrecht the way to go or a derivative of it. So it's not specifically measurand Eichrecht, it also covers measurand Eichrecht. And to be clear, this document focuses on the signed meter values. when you have different tariffs. At some point, we might want to start a discussion on having signed tariff information as well. But that's been out of scope for this document. Otherwise, the whole discussion would have lasted probably a lot longer. But know that in the future there might be an update to this one to include tariff information. Then the concepts. So there are a lot of different meters out there. Every meter chooses their own way of publishing that information on their communication port. They're all signed. If you want to comply, you have to have a meter that produces signed meter values. But what that information looks like may vary from meter to meter. So that's also a charger problem. But it may also become a cloud problem if a meter cannot read certain information when you want it. So Robert will address that a little bit more in the details. And as I mentioned, I think to keep in mind is this is about end-to-end. So it's not just about the charger. The purpose of end-to-end is that certified meter that produces signed values, those signed values should end up in a CPMS, but it should be provable that those values that end up in the CPMS have not been tampered with. So that's why it's important to understand this as an end-to-end. The charger communicates with the meter, and it may get start and stop and intermediate values that are signed, and it needs to deal with those. Again, Robert will speak a little bit more on this. The charger sends the meter values to the CPMS via OCPP, but of course the CPO can share those signed meter values with the mobility service providers. That's up to the use case and to the CPO. CPO MSP communication for us is out of scope because there are different protocols there, and those are not under our control. But it doesn't mean that it won't work. Of course, those protocols also have provisions for this. And last but not least, when those values do show up and in the CPMS, and an end user wants to view the proof that the meter values are correct, you need special transparency software. That special transparency software again needs to be made available by the charge point manufacturer because it's their choice on how to solve it. That doesn't mean that there's a whole range of tools out there. Fortunately, most charge point manufacturers make use of standard open solutions for this. But keep in mind that next to OCPP to deliver the message, the values, you also need transparency software to prove the values if people ask for it. So this is where my story ends, and I give the floor to Robert.
Thank you, Patrick. So when we came to designing this into OCPP and finding standard ways, one design goal was to be consistent across OCPP versions so that it doesn't change, the solution doesn't change between OCPP versions. And when this white paper was started, actually the assumption was that OCPP 1.6 needed some additions, and OCPP 201 was assumed to have everything we need. But in discussions in the Open Charge Alliance technical working group, it turned out that OCPP 201 actually also still had some gaps. And we started filling those gaps within this application node. And in the end, these additions we made to OCPP 201 ended up being incorporated into OCPP 2.1. So what we have now is that this application node contains additions to OCPP 201 that are already found in OCPP 2.1. And the solution is pretty much identical for OCPP 201 and 2.1. Charging station manufacturer will typically use the same device model for 201 and 2.1. At least that was what we expect. And then it doesn't matter whether you add these things that we specify here to OCPP 201 and then later implement 2.1, or whether you implement 2.1 at some point, you will also have it in 201. So you only have to implement it once, and then you will have it in both 201 and 2.1. For OCPP 1.6, we also try to stay consistent, but OCPP 1.6 has a bit different structure. It doesn't have a device model, so we had to adjust these things a little. That's why it's a backport, but for 2.1 and 2.1, it's the same solution. For 1.6, it's a different solution, but that can still use the same business logic as the other ones. So if you build your charger, you will have one business logic for your signed meter values that is slightly differently exposed between 1.6 and 2.x, but it's still the same thing except for the protocol details. And now we're getting to the next slide, please. Yes, and so the first thing is how actually to configure that meter values, signed meter values are sent. And well, OCPP 201 already foresaw a variable called sign readings, but it was not detailed enough. It didn't, because you can have signed meter values at the start of the transaction, during a transaction, and at the end of the transaction. And there was just this one variable, Boolean variable, that says enable signed meter values or enable signed readings, but it didn't specify which of the measurements are signed, because you might not want all of them to be signed. And so we added variables to add this detail. That's for the signed started readings, which are also Boolean variables, signed started readings and signed updated readings. And the sign readings address was because we're only trying to be backward compatible with what already had been specified. So we're not changing the meaning of variables that have already been there. We're just extending the meaning, if you will. So the sign reading values address already was in OCPP 201 remains this global enable for the signed meter values. So if you send it to false, the charging station will not set any signed meter values. But if you set it to true, these additional variables specify which of the readings will actually be signed, have signed readings in them. And these variables, the additional variables can be read-only variables. So because you might not be able to change the way your meter works. So in the easiest sense, if you already have implemented it and you already have the sign reading values, you might only just have to add these two additional variables specifying which of the meter values you're signing when this global enable is set. So that's pretty much minimizing the effort on implementing it to get in line with this paper. We have the full details on this because it's not just signed started values and signed updated readings. Actually, it's also differentiated between the sampled meter values, the periodic ones, and the clock aligned ones. So there'll be a few more variables. But in the easiest case, if you already have a charging solution with certified signed meter values, then you can just add these variables to add the missing pieces to give clarity on which of the values you're actually signing. Then OCPP 201 already had this public key with signed meter values variable, which is used as it was specified, just with a few more clarifications. And then the fiscal metering, I'm not sure if that actually was already specified now, but at least this has a variable now. So you can either specify this through public key with signed meter values that you want the public key to be sent along with the signed meter values. Or you can say, well, actually, I don't want all that data volume. This public key is unlikely to change unless you do a hardware change to the charging station. So we just wanted to be readable on demand. So we just offer it through a device model variable. But the problem with both of these is whether you transfer the public key with the meter values or if you read it through a dedicated variable. The problem is it was not specified what the contents of this public key actually was. Which brings us to the next slide. Patrick? Yeah, thank you. There were some fields defined in OCPP 201 already, but it wasn't clear what to put in these fields. Just says, well, here's a field to put a signing method. But there's no one way to specify a signing method. There's many ways to do it, and we added a specification of what values you should put in there or are supposed to be put in there rather than just saying it's something, because that's not interoperable. If everyone comes up with the same idea of how to put which values in there, that's not interoperable. That's why we added the filters gap and add some values. Added the values, we will hopefully all the ones that we need, but if more are needed, you can contact OCA and say, well, we actually have a sending method that's not on the list. Could you add that to the document? And then we can publish that as well, and so that everyone uses still the same values. And the public key one was especially challenging because public key just as well as a space 64 string that contains the public key, but there's also not this one pump format into which to put a public key. Maybe for RSA it would have worked if there were only RSA keys. You would say, well, okay, there's a key, and by the length of the data that I extract, I can tell the key length. But as soon as we're getting to elliptic curve keys, you cannot just derive the key from some sort of blob, and that's not obvious. So there was just something missing. Another challenge that was also missing is that the process of the customer being able to verify whether the readings he got invoiced for are actually the ones that originated from the meter, is that there's supposed to be a window in the charging station through which the customer can see the meter, the certified meter. And the certified meter, he cannot read the meter reading, the current energy counter, but he can also see the public key, which is printed on the meter. So the problem, he might take a photo, for example. The problem, of course, is then the customer only has this printed public key and not some sort of binary representation of it. So we said, okay, in this, so again, we say backward compatible. The specification says there's a base 64 string, so that's unchanged. The public key is a base 64 string, but when you decode this base 64 string, you will get what you get then is specified here. And at the end of so we said, okay, the one part of it has to be the public key as it is printed on the meter. So this may be typically they're using base 16 or base 64 encoding when they're printing it on the meter. Then we prefix it with the metadata you need to make of this public key, because it's not obvious. So and the first thing we added was a marker, so that when you see, okay, I decoded this public key, now I check the first 3-4 characters, and if it's okay, OCA and a colon, then I know, okay, this is this format that's specified in this document. Then we have the next composite part is the encoding of the public key at the end. So it's, for example, the ones we specified now is base 16 or base 64. That's the only ones we could think of. So then you can decode the public key as it was printed on the meter. And then what is that public key? What format is it in? A typical format is an ASN1 structure, which then has this OIDs with a key length with parameters, and then the actual key as a binary blob. So that's what you will typically get. And that's now you get all this information when you get this composite string. And at the end of the document and at the end of the presentation, we will show you such a composite string, because, well, you can explain a lot of words, but if you implement something and, well, you get a result, you're saying, is that now what the authors intended or not? But so that's why we have examples there so that you can verify if what you're getting is actually what was intended by the authors of this document. Next slide, please. Okay, so the OCPP 1.6 backport, as mentioned, is a bit, has to derive a bit from the 2.x ones, because the main problem is star transaction request cannot contain signed meter values. There's simply no way, no field in there. In 1.6, 2.01 it uses the same messages, or 2.x uses the same messages for start, intermediate, and end. And they all can contain assigned meter values, and they can be configured which measurements they contain. Start transaction cannot contain it. It only has one field to have a meter start reading, which is not signable, and you cannot. So the solution we came up with is that the charging station generates a meter values request to be sent right after the start transaction request, which then contains the start readings. So just normally that's not foreseen. Normally you send a start transaction, then the next thing you send in a meter values request is the first intermediate readings, if any are configured, or maybe none. But now we changed that and say, okay, the thing we can transport in one message in OCPP 2.x, this start transaction message with containing the signed meter values is sent as 2 messages in OCPP 1.6. So that's something that wasn't foreseen in 1.6 that way. But that's the vehicle we use, so that we cannot change the messages, we cannot add any fields. So that's the solution we came up with, that you send a meter values request right after that, containing the start readings with a transaction begin context, so that the CSMS can also see, okay, these are the start readings, even though they're in a message that is actually normally transporting intermediate values. And also 1.6 specified that the sampled value field is a string that can also contain raw values, which is normally used now, but it can also contain signed values. But what's in there when you configured signed values was not specified at all. So we filled that gap and saying, okay, if you follow this white paper, this sampled value field in OCPP 1.6 meter values request contains the signed meter value value type that is specified in 2.x. But of course, it's not part of the message. It is a separate JSON string that we have to encapsulate to send it as a string field value in the surrounding JSON of the meter values request. Also, yeah, because it's a bit complicated to explain, we'll also have an example at the end of the document and also at the end of this presentation. The configurations keys, as I said, are the same as in 2.x, but of course 2.x has a device model for configuration, 1.6 has configuration keys, so we have to have a sort of a mapping between the device model variables and the configuration keys. That's also specified which configuration. So for the 2.x, the device model variables are specified, and 1.6, the configuration key names are specified in the document. Next slide, please. Yeah, now we get on to the examples. Yes, next slide. Yeah. And so the 1.6 stop transaction, that's, if you see sorry, it's a bit detailed, I hope you can all read it. But the text in bold is the standard OCPP 1.6 stop transaction message. So that's a normal message as it existed. And in the sampled value, it's also the format signed data that was specified. But what the content of the value field is, that's what we specified in this document. And as you might be able to see in the third line, there's the double quotes in the string are escaped. And if you can read it well enough, you will see that it's actually a separate JSON structure in there with the fields signed metadata, encoding method, public key fields. So these are the fields. This is the same content. If you decode this JSON in a second step, you will have the same fields that you have in this one OCPP 2.x signed metadata value type. So it's just a different way to get this message into, or this data structure into this message and get it out of the end. But what you get after this extra step is the same thing that you get in OCPP 2.x. And now the next slide, please. And the public key. So the public key is an example. So here we have an example how to what the charging station manufacturer would do with it. So they would somehow get this public key as it is printed on the certified meter. Well, obviously you cannot get the exact formatting and font, but it should be easy enough for a customer to verify that this is the same thing he's seeing on the meter value, on the physical meter. So if, for example, this was an RSN1 structure and containing some parameters as well as the actual key in base 16 encoding, that's the example at the top, then we would add this prefix with the metadata, which would be the OCA marker followed by colon, then base 16 as the encoding of the string at the end, and then ASN1 is the type of the encoded data that you get. And when you have created this composite string with a colons in it, you would base 64 encode it again, and that's the value as you see at the bottom. That's the string you would put in the public key field, either with the metadata or with the device model variable as a value of the device model variable, or the OCPP 1.6 configuration key, which are all specified in detail in the document. And I think, do we have any more slides? I'm not sure. Yeah, that wraps it up for my part. So now we are open to questions.
Yes, so thank you very much for presenting, Robert and Patrick. So now it's time to start the Q&A session. We also have a panelist who will join us. That is Frank Buve from OCA. So he's sitting next to me, and he will also help answering your questions. So the first one is, what is the usage of the transparency software? Have you tried it? And are those signed meter values easily available to the consumers from the CPO, EMSP? And who cares if there is some trust to the companies? Not sure if the question is clear, but
Yeah, I think the question is clear, at least to me. So as an EV driver, the consumer, you may get the key on your invoice or on your receipt, and where to go from there. Well, your CPO and or MSP needs to provide you with information on how to validate that value. So they need to publish through their own website if you want to validate your Eichrecht conformity of meter values. Use this link, and then you can access the transparency software. So it's to the CPOs and MSPs to publish that information.
yeah, all right, I think it's clear. The next question is, could you say something about the patent situation in Germany regarding the signed content? So to get a, yeah.
I am not a patent expert, to be honest, so perhaps one of the other.
Sorry, unfortunately, I'm not either, so I don't know.
Yeah, no problem. So we don't have the right experts for that question, but I hope we can help with other questions. So let's see. The next one is there a way to send the meter certificate so the chain can be verified in the back end, or is the chain supposed to be known? I don't know who can take up this one.
So the security certificate of the charger stays in the charger. It's quite normal that that's why it's called a public key. You only publish the public key. So the exact certificate, that's the whole point of security, will stay in the charger, in the meter, I should say. And if at any point in time the meter needs to be replaced, it will be replaced with a meter that has a different certificate and will have a different public key. But yeah, again, only the public key will ever be exposed. Otherwise, there's no security.
Yeah, all right. Then let's have a look at the next question. Let's see. Is the example of looking at the example of stop transaction 1.6 with the encoding method OCMF, does this also include the version used?
No, I'm not sure. Actually, the OCMF is a container of its own. I'm not sure if the container itself contains the OCMF version. So unfortunately, I don't have a good answer on that.
No, that's all right. Okay, let's have a look at the next question, which is when will the white paper be available? Can we? Do we have a date?
I think Frank is talking, but he's on mute.
Yes, I can. Yes, the white paper is already available.
Yes. So yeah. So Frank made it already clear. The white paper is already available. We had some sound issues here, but it is already there, and you can find it on the OCA website. So let's see. The next question is there any official transparency software from any government body to validate the conformity of the billed value?
So the way I know it is that it is up to the charging station manufacturer to provide this transparency software, and maybe they can, but it's not implemented by a regulatory body. So the regulatory body tasks the company which wants to put a certified meter in the field to provide the software. So there's a legal requirement for the manufacturer to come up with one, or at least the operator in the end, but the operator will load it off to the manufacturer. But it's not like the government body itself will provide a transparency software. They are checking, they're certifying the software, they're requiring documentation from the customer, and they're checking that it's working as it should, but they are not creating it themselves.
Mm-hmm.
Yeah. In addition, so the responsibility is on the charge point manufacturer, but charge point manufacturers don't make this software themselves. They usually go for already available open source solutions. There are a few, but it's very limited. So most will choose the exact same solution.
Yeah, all right. Thank you for clarifying. Yeah. So let's have a look at the next one. Are signed data only used at the end of the charging session?
Yeah, well, that's so. Actually, we tried to write that in a document at some point, but we found out that that doesn't suit everyone. So some manufacturers said, no, we need to get this data out of the charging station as early as possible. We don't want to keep it around and wait for the end of the transaction. Also, some operators said, well, actually, we want to have it as soon as possible to verify that our meter is valuing correctly. So we don't, if in case the meter doesn't work right and doesn't provide correctly signed values, we don't want to have full transaction to finish. So in the end, we had to offer this flexibility. It's with this additional configuration variables. If the additional variables are not read-only, it might be configurable. Otherwise, there might also be a limitation due to the way the certified meter works, and you cannot change that. And so if a certified meter gives you intermediate values of values at the start, you cannot just say, well, I actually only want them at the end. So we had to add this flexibility. We couldn't just say, well, only at the stop, because that makes more sense to us. But there are different use cases and different hardware situations in which you cannot just change it. So we had to offer the flexibility to have them at the start, the intermediate, at the end, or only at the end, depending on these variables, which at least expose how the charging station works, even if it's not configurable. At least you know what you're getting, which is a bit unfortunate for the operator, because they may have to piece together from separate messages the information they need to invoice the customer, but we can change that if the certified meters that already exist work that way. The CPO will have to put up with that, but at least he knows what he's getting by the variables we added.
All right. Yeah. Thank you. Then we'll have a look at the next question. I know that some certifications require the Paginierungszähler to always increase by the same amount per charging session. As far as I understand, that will prevent to sign transaction updated meter values, because the number depends on the time of the charging session. Do you know if certification processes have been updated, or if there are certifications which do not require this? So it's a long question.
So I'll have to pass on that one. I'm not enough into that to know. So yeah.
Same here. It doesn't ring a bell for me.
Yeah, no problem. We can't answer all the questions. So let's have a look at the next one. Some transparency softwares use XML format instead of JSON. Any suggestions on this implementation? Or yeah, on this one. So XML instead of JSON.
Yeah, so it doesn't really matter that much. Our solution describes how you transport the meter values through OCPP. Then those signed meter values end up, as mentioned, with the CPO and or MSP, and they need to make the transparency software solution available to the customer or reachable. what you typically get is an interface where you insert the values that you want verified, and how that input and output is done by the tool itself. Yeah, that's not relevant for this solution.
Yeah, all right, thank you. Next one is, does CPO mandatorily need to show signed meter values and public keys always on the invoice or receipt? Or is the requirement for CPO to have these values with them in case a driver asks for it?
Yeah, I don't know. Perhaps you know, Robert. I would say the user must have access to information if they need. That doesn't mean that it needs to be published, strictly speaking. But if a user contacts you, you must be able to supply that information. Now, if you don't supply that information and the user, the driver, needs to contact you, that means manual work. So it's probably easier for the CPO to include that information so that if people have questions, they can look it up themselves instead of calling a help desk. But that's a company decision. That's not part of our solution.
Yeah, all right. Then we got a question that maybe you can take over, Frank, because it's about the California pricing model. So could you say something about the differences to the solution in the California pricing model?
Yeah, I can say something.
I think, Hanno, you need to mute your output.
Sound is normal again now. Yeah, so the California pricing regulations is quite different. The California regulation focuses on the fact that you need to display the prices in near real time on the charger as the transaction progresses. And it does not say anything about how the meter values are transported then to the backend and to the mobility service providers, for example. Whereas Eichrecht doesn't say anything about how you need to display the prices or whether you need to display prices, but it just says how you can securely transfer the metadata and prove that it has not been tampered with. So it's different, and even they could even be complementary, these solutions.
Yeah, so thank you, Frank. So let's have a look at the next question, which is when will the signed tariff information be included, and will it also be backported to 1.6?
Well, as I mentioned, the signed tariff information is not there yet. If we as a community want to add that information, and we as a community need to have the discussion on how to do that, what to include. So that would be typically a technical workgroup discussion, or a smaller group that prepares it and brings it into the technical workgroup for OCPP. And that discussion hasn't started. So if people feel this is urgent, then I would encourage them to start that discussion in the technical workgroup.
Yeah, all right. Thanks for that comment. We also often get a quite general question, so if the slides will be shared afterwards, so maybe it's good to talk about that. So we will post the webinar recording on YouTube in a few days, and then you can always check back and watch this webinar again. So that's good to know. The next one is, would OCA consider their own transparency software spec or tooling? Because it seems that the incumbent is a bit messy, outdated, and requires registration on a German-only website. So the person who asked the question says that I think it would benefit everyone if there were easier or better ways to achieve this. I don't know if, Frank, you can...
Yes, I can say something about that. Yeah, actually, the whole Eichrecht is a specific German solution. I don't think it's up to Open Charge Alliance to provide some tooling for this. And yeah, I think that there are open source tools available already in Germany. It's a German regulation, so I think we should leave it there and not invent our own OCA tool, because then you just have yet another standard tool. I don't think it will replace anything that's already out there in the market. So I don't think that's a good idea.
So if I may add to that, if the problem is that the website providing it is in German, then I would encourage everybody to send an email to those websites to also make a English version available. Small effort, but a huge help.
Yeah, that's a good one. Then we have another question, maybe which Frank can pick up. So how do we make such an application note? Can you maybe tell a bit about the process?
Yes, I can tell a little bit about the process. This topic came up in our technology working group meetings that we have every 2 weeks online with our members. And yeah, they reported that there were many different custom implementations of Eichrecht going around. For every manufacturer had its own solution. And there was really a desire to get a kind of standardized way, because now CPOs, they have to provide support for all these different charging stations that have different ways of representing their signed meter values. So then we asked around among our members, who has some experience with this. And we had members from several companies, 2 of which you see here now presenting them, that volunteered to dive into this matter and write a white paper on this. And yes, some other people were also involved, but in the end it was Robert and Patrick who finalized the paper, for which we are very grateful. And this also shows that, as OCA members, you can really contribute to the protocol and to the community, because if you have some good ideas or solutions that you want to share with the rest of the industry, you're welcome to do that within the Open Charge Alliance.
If I may add to that as
yes,
well.
Thank you very much, Frank. And Patrick, so the floor is yours.
Researching the topic is a step. So if not specifically for this one, but for any topic, if you want to add a white paper, add a note, you need to research the topic. Then we bring our findings to the technical work group, as Frank mentioned, to have that discussion there, to get a feel for what the community thinks, what we are overlooking, what the priorities are. Then you typically take the effort to actually write the document. Once you're confident that your draft is okay, you bring that back again to the technical work group. Usually that leads to at least a few iterations of improving based on feedback. And then you near the end of the process, your draft becomes semi-public, so available to all the OCA members for feedback. If there's no more feedback, then we publish it. And then the last step, which is also a good step, I think, is organizing a webinar to explain its existence and to summarize how to use it.
Yeah, good one. All right. So let's have a look at another question. Why don't you add email end users to the OCPP extension to be able to the CPO to send an email at the end of the session?
So the meter, so to send an email to a driver, you would need to know the driver. The meter doesn't know the driver, the charger doesn't know the driver. And if it's well organized, the CPO also doesn't know the driver, only the MSP does. the CPO can exchange transactional information for a specific RFID with the MSP, but only the MSP and their system would be in a position to send an email to the driver.
Mm-hmm.
So, or I'm misunderstanding the question.
Yeah, no, I think it's clear. So let's see, there's another question. What if a meter is replaced? So the public key will change, but can we still validate old and new transactions? And does this mean we would have to redo our implementations to be compliant?
No. So the old transactions, the transactions on the original meter, will have the key of that meter for all those transactions, so they can always be validated. Replacing the meter, typically it's replaced with a meter from the same manufacturer, so everything is done exactly the same. If not, then your charger might need a software update to communicate with a different meter, but that's up to the chargeable manufacturer. Regardless, in the end, the new meter values of the new meter, including its new public key, will be made available to the CPO through the transactional messages, and therefore also the new messages can be validated. But yeah, the old meter and old key for old messages, the new meter, new key for new messages.
Yeah, all right, thanks. Next question is about 1.6. So for 1.6, do you know if there are a lot of vendors who are using, let's see, do you know if there are a lot of vendors who are using or have plans to use the signed meter value type format specified in the notes?
So that's a bit of a complicated answer. And this application note has just been published. As you have seen from the slides that Robert presented, there is a prefix OCA. Implementations pre-existing this node will not have OCA in there. I've looked at quite a few different implementations that are already on the market. Most of them are sort of similar. Updating the firmware to use this method for most implementations shouldn't be that difficult. And when they do, then they are compliant. But yeah, pre-existing implementations, and that was basically the reason why we started writing this note. Pre-existing implementations are very diverse. So no.
Yeah, all right, thank you. So let's have a look at some final questions, and I think then it's time to wrap up. So one question is, OCPP 1.6 says that with signed data, the value should be opaque, digitally signed binary data block represented as hex data. This is another format. Have you considered a standard parameter for selecting the format to use? Maybe that's a question for Robert, but I'm not sure.
Yeah, no, we didn't specify any. So the OCP 1.6 already had this two types of this two values for the type of meter value data you get. It was either raw or signed, and we just changed specified what you get when it's signed data. So yeah, if you have an existing solution that sends something else in there, you should still be able to tell that it's not this JSON block that we specified in this application note.
Yeah, all right. Okay, so thank you, Robert and Patrick, for presenting today. We're really happy to have you here. Do you have any final remarks to wrap up the webinars or something you want to share with our audience?
Not particularly. I think it was fun to do this. I hope it will start getting used very quickly. if there are any additional questions, as you can see on this last slide, we included the Open Charge Alliance email address. So they can answer it, they can forward it to us. So if you have additional questions, if you're watching this webinar after it's finished, feel free to reach out to the Open Charge Alliance with additional questions.
Yes.
Yeah, I would say this concludes a long journey for this paper. So the first draft was actually handed in at the end of 2023. And so here we are in March 2025. So it's been a lengthy process, but it also takes some time to get all the OCA members, all the industry partners to give their input into, because the point of this paper is really to get something that accommodates every use case. If you just write something that doesn't work for everyone, people just won't do it. There's no requirement to do this. We are offering this as an interoperable solution, and we did our best effort to make it work for every use case scenario, every hardware that's out there. Whether people will adopt it or not, we will see, but we've made the effort to make it adoptable for as many people as possible.
Yeah, all right. That's a nice
So
conclusion.
if I look back, we answered the question about process. That was very content focused, but indeed Robert makes a very good point. I think most of the effort actually goes to getting consensus on the solution so that people support it.
Yeah, that's a really good one. That's the way how it starts. Eh? Yes. All right. So thank you for your final remarks, and yeah, to our audience. So we hope to see you again soon at one of our webinars or live events. So if you want to stay up to date, you can check the event calendar on our website, or you can follow us on LinkedIn. And as Patrick said, you can always share your questions with us. So you can email us at info@openchargealliance.org, and then we will come back to all your questions. So for now, it's time to stop the session. Thank you very much for presenting to our guest speakers, and thank you for attending and asking so many questions. So goodbye and have a good day.
Thank you.
Bye.
Bye.
Bye.